Reverse engineering, primarily known as reversing, is a very important part of hacking and cybersecurity. As we can determine from its name, reversing is all about reversing things. Reverse engineering might seem so complex that not everyone has the bravery required to tackle it. But is it really that hard? Before jumping into how we can reverse engineer, let's first understand what reverse engineering is. I have a simple example to help you easily understand reverse engineering. Consider yourself a computer programmer currently programming in C, which is one of those languages that uses a compiler instead of an interpreter. You write a simple program, let's say a Hello World program in C, and then you compile it. After compiling, you have an executable file that will work according to what we wrote in the source file. In our case, it's a simple Hello World program. When we execute the file, it simply prints Hello World height on the screen because that's what we programmed inside it. Now let's say we lost the source file, so we can't read what was written inside our program. If we try to open the executable, it simply gives us random garbage data. This is where reverse engineering comes in to help us figure out what's going on. This was just an example. In the real world, hackers use reverse engineering to steal information and perform other malicious activities. One of the most notable uses of reverse engineering is cracking. Hackers use their reverse engineering skills to crack commercial software and sell them to earn money. On the other hand, ethical hackers use their skills to test such software and make them stronger against potential attacks by malicious hackers. Reversing is also used for malware analysis, which is another crucial part of ethical hacking and cybersecurity. Alright, now let's get into how we can get started with reverse engineering. I've divided the process of learning reverse engineering into 3 major tiers. Our first tier starts with learning assembly language. This is for when you have nothing but a strong desire to learn reverse engineering. Assembly language is a must for learning reversing. It doesn't really matter which assembly language you learn first, because most are very similar. According to my suggestion, you should start with x86 because there are many resources available for it, and more tools support it than any other language. Some of the best resources to learn assembly and reverse engineering are pinned in the description. You should also have a basic understanding of executable file formats like PE for Windows and ELF for Linux. Once you've learned all these, you'll be ready to move on to the second tier. This is the phase where we actually start reversing things. Start using different reverse engineering tools, such as Ghidra, which is completely free. You can install it using APT on Debian-based systems or Pacman on Arch-based systems. Radar 2 is another free tool for reversing. If you prefer paid tools, you can choose Binary Ninja or IDA Pro. IDA is the oldest of them all and is still considered the industry standard for static reverse engineering, though it is the most expensive option. If you're a beginner, I recommend starting with Ghidra. After all, it's free, feature-rich, and has tools that other free tools don't offer. There are plenty of online tutorials on Ghidra, and there's a solid book called the Ghidra book. Once you get your hands on reverse engineering tools, start creating simple C programs and reverse engineering them. You can begin with the easiest one, like the Hello World program discussed above. Then, learn how debugging works. Debugging is the process of dynamically examining and modifying the workflow of a program. Your go-to debuggers are GDB on Linux and x64DBG on Windows. Tier 3 is where it gets real. It's time for you to get your hands dirty and work on real-life scenarios. This phase allows you to explore different aspects of reverse engineering and choose the areas you want to focus on. The first step is to find some challenges online. You can start with simple Crack Me or Pun College challenges. These are great places to put your reverse engineering skills to good use. Then, learn about common security vulnerabilities in software and try to find and exploit them. You should also learn about packing and obfuscation. Although these aren't super common in legitimate software, they are often used in malware and similar threats. Participating in CTFS, the flag challenges, is another great option. There are many CTFS available for all skill levels. All CTFS are time-bound, but don't be discouraged if you can't solve a challenge right away. Take your time, there is no rush. Finally, try to reverse engineer real-world systems. For example, attempt to gain root access to your home router. So this was a beginner's guide to reverse engineering. As a final thought, I want to say, never stop learning. Find online tutorials and connect with people who are already doing reverse engineering. You can join different communities on Reddit and Discord and subscribe to useful reverse engineering channels on YouTube. I plan to start a video series about reverse engineering where we will learn from the very basics. Let me know what you think about it. Subscribe to this channel and like this video if you're interested in reverse engineering and other hacking-related topics. Until we meet next time, happy hacking.